Hey guys, what's going on? Today we will learn a very interesting topic about the SYN flood attacks and SYN cookies. The best way how to learn this is to create our little topology in GNS3 lab and try it out. So let's call our little virtual friend and he can take it over.
A TCP SYN flood attack is a threat that should never be allowed to reach a critical server. This video will examine precisely what a TCP SYN flood attack is and how to stop it from reaching a critical server. We can suffer from a SYN flood attack in a typical environment if we have clients and servers. The client sends TCP SYN synchronization requests saying that it would like to communicate with the server. Upon receiving the packet, the server responded, "Yes, I would also like to speak with you." When it comes to SYN ACK, it is an acknowledgement of the initial synchronization request as well as the server's own synchronization request, followed by the final packet from the client, which is an acknowledgement ACK. The three-way handshake consists of SYN, SYN ACK, and ACK packets. 3 packets are normally exchanged during a three-way handshake. What would happen if you sent thousands of TCP SYN requests? While the servers were looking for and awaiting the final packet to arrive, we could tie up the resources and bring the server to a halt. By using SYN cookies, a server can avoid dropping connections when the SYN queue fills up. An entry in the SYN queue is encoded into the sequence number sent in the SYN ACK response rather than storing additional connections. By using the information encoded in the TCP sequence number, the server can reconstruct the ACK queue entry if it receives an ACK response from the client with the increment sequence number. After that is done, a three-way handshake is established. It is possible that the source address may be lied about in a malicious environment. There is a packet coming from 1.2.3.4 or some other random address, which is not really his address. In fact, the packet goes to the server, and the server now responds to the fraudulent address. In addition, the client who owns IP is also a victim, receiving all of these TCP SYN ACKs that were never requested in the first place. To demonstrate SYN flood attack and SYN cookie technique, we use GNS3 environment. GNS3 is used by hundreds of thousands of network engineers worldwide to emulate, configure, test and troubleshoot virtual and real networks. GNS3 allows you to run a small topology consisting of only a few devices on your laptop, to those that have many devices hosted on multiple servers or even hosted in the cloud. Packet filtering allows legitimate external users to make inbound requests to your web servers. An ASA protects internal networks by permitting valid packets into the DMZ and only there. With packet filtering set up on an ASA, internet users making valid requests can access public web servers. At the same time, we're never allowing external users from the outside into our inside zone. That's because everything we know about zone perspectives is maintained when dealing with packet filtering. Our solution would be to have the ASA step in and refuse to allow so many half-formed sessions to reach the server. It is up to ASA to set the threshold. If there are more than 10 half-open TCP sessions, sometimes referred to as embryonic connections, ASA will take action. The network tool Ping3 is used to test the connectivity between the server and the attacker. Ping3 is capable of sending custom packets and performing a wide range of network tests. The following example illustrates the use of Ping3 to perform a SYN flood attack on web server 10.1.1.1 on port 80. In this case, we only send packets with SYN flags and do not wait for the web server to respond. To accomplish this, Ping3 uses the following switches. S. Set only SYN flag. P. Set port where traffic is the target. Flood. Send packets on rapid phase and do not wait for a response from server or RST traffic. The policy on the ASA will be implemented using a modular policy framework that uses class maps to identify traffic. In this case, we have a class map called SYN class which, if it matches access list SYN ACL, then it's traffic that's headed towards the DMZ server. Our second step is to create a policy map based on the data we have gathered about this policy map. We are making use of global policy. If the traffic matches the class SYN class, global policy states that the embryonic connection should be set to a maximum of 10. In the event that traffic exceeds this limit, the TCP intercept function will take care of it. As a result, our server only has to handle 10 half-form TCP sessions at a time. It is important to note that even though there is still a DDoS attack underway, the web server is now available to start communicating from inside as well as establish a full connection from outside. According to packet capture between the ASA and the attackers, there are thousands of SYN packets and the firewall replies with a SYN cookie on behalf of the web server. Capture between ASA and server, there are only 10 SYN packets going from server to outside. SYN flood DDoS attacks on your network can be prevented or eliminated by using this technique.
Thanks everyone for watching, and I hope that you learn a lot, and I'll see you in the next one. Peace.